my name is Janos and I will talk about benchmark LIO EKF to HDMapping. Let's start with clicking this link. So we are using hint, and please change branch to bunker DVI dataset. And we have simplified instructions. We have already done step 1, so we just jump to the step 2. So let's open new terminal and follow instructions. So we just copy paste instructions, we go to our folder, we clone repository, we go there, we change branch, and we build Docker. I can see it takes a while, so let's cross fingers that everything will be okay. Still a lot of time that we need, so maybe I will show you where to find information about this LIO EKF publication, if it exists, obviously. So the idea is that we concatenate all information into one website, our project website, so you can find everything you need there. So this is LIO EKF. So it is a link here, and we have this LIO EKF high frequency LiDAR odometry, LiDAR inertial odometry using extended Kalman filters. So you can see everything here, and I hope this information can help you understand more about this algorithm. So it was published on the ICRA conference. Let's find the way. Let's find the where it was published. So LIO EKF, if you take, yes, it is from ICRA, so in 2024, so it is quite fresh algorithm. So let's take a look into it. It is still building. Yeah. So maybe I will tell you something about the data set that we prepare for that. So we are using data set that it was collected with our colleagues from Royal Media Academy of Belgium and Ghent University. These are authors, and what they did, they collected fantastic data set in Bunker, and the advantage of this data set is that we have ground truth. Ground truth is done with geodetic LiDAR. It means that we have fantastic opportunity to compare against the high quality ground truth. And this data is extremely interesting, since it is collecting narrow passages in very, very difficult conditions, that you can have different light conditions, and so on and so on. And the data was collected with the system equipped with 3D LiDAR, active stereo camera, passive stereo camera, time of flight camera, and multiple inertial measurement units. You can read about this sensor more here. So you can see that you have plenty of sensors on this device. So you can work on plenty of algorithms. We decide to use this data set and to use it to validate 20 algorithms here. So in each algorithm we provide a movie of the experiment, exactly the same what I am doing now. So you can use this movie to reconstruct your experiment. And obviously speaking, we have to-do list. The to-do list is rapidly growing because there is a growing interest on mobile mapping thanks to LiDARs. So you can see that plenty of LiDARs are affordable, more affordable than before. So you can use them to build maps. And our project is, the intention was to make a project that can help in building maps of entire cities. So if you jump into details of our project, you can see that we can build maps of the cities. It is not so obvious that it is easy, but it is possible. And we are struggling now with plenty of challenges that can help us to make these maps much easier. So for example, we provide HDMapping, LiDAR inertial odometry, we provide postgraph SLAM, we provide georeferencing, and we are focused now on automatic loop closure. So what we do now in our research, we are trying to solve this issue, looking at massive calculations point of view. So we will collect data for that. Okay, I will pause my recording and I will back you in a second. I'm back. Hello again. So you could not see this break because it was longer for me, but for you it was like a second. So we go to the third step. We run the experiment. So we change some parameters of the files and we go there, and then finally we launch experiment and we will see what happens. Okay, so it is running, and let's observe. So we put it on the right side and I will show you the data set, and definitely it is not a drone, so we do not elevate. Give me a second. So this is our data set. I discussed, I hope, in this movie before. If not, I think I discussed because we have plenty of time. So let's wait a moment, I think I will stop here and I will back to you within a second. Just wait till it is finished. Oh, I cannot click. Okay, hello. After small break, I decided to show you how it works. So we are approaching the end of the experiment, and I hope all of information will be saved in proper file, so we can continue exporting your point cloud and trajectory to perform qualitative and quantitative analysis afterwards. So you can see that the trajectory does not look like our data set on the left side, but this benchmark is about end-to-end experiments, so please be patient. I think we approach end, so let's go back to our data. What is the application? Files has closed. I don't know. New window. We have our benchmark, and we expect data in new folder that it will be LIO EKF. Where is it? This one. This is LIO EKF, and we have inside plenty of files, and we are looking for a session that can be opened with our software. And our software, you can download it from GitHub. This is HDMapping build bin. This is our multi-view TLS registration step second. So you can open session, then you look for the session file, yes. And once you have session file, you can export it. Obviously you can see more data once you reduce by 0 here. You have all data here, so you can simply export, so you can save all marked scans as a global scan. So LIO EKF, and you can have PC global.laz, and you can export also trajectories in XYZ quaternion format. So trajectory global.l, not laz, CSV, and we can use this in Cloud Compare. So what you have to do is only drag and drop the files that we exported, so PC global and trajectory global. And trajectory global, XYZ coordinates and timestamps, apply all, and we have everything we need to perform qualitative and quantitative analysis afterwards. So you can see partially the algorithm retrieved some structures, but I don't think so. It is working very well. That's all, I think, what I would like to say at this moment. See you in next movie. Thank you for watching, for listening.